That's not good. That's not
You need to have a girl on the freeway for it to not be safe.
I mean, I can be kind of cool. JJ calls it girl.
This is true, but it doesn't count.
You even JJ.
I don't want to say it. I don't want to be that high.
Don't you knock my boyfriend?
I will.
Why not?
Why not? It's fun. Try it. I sound like a horse.
Well, just like every, like, the most recorded, the highest.
No, my wire cost was long. It's 2 hours.
All states like 4.
There were 13 soloists.
I heard it was like you guys sing for 2 minutes and then they sing for like 5 minutes and then you for 2 minutes and then 5 minutes.
Yeah, I had to stand there the whole time. Once we had dress rehearsal for 3 hours that morning, then I had to stand the whole time for that. My legs still work on it.
It's an article from 1969 showing how untrue it was.
My legs hurt from standing for 5 hours in a single day. Uncramped risers.
This is why
You have. At least they're like it's more comfortable.
We're still waiting for the class to start.
It is time. It's Monday. Just met with Doctor Who, and we're going to take you into the time machine. We're going to go back to 1969.
Oh, God.
Anybody know what happened in 69?
Ended on the moon.
the summer.
The moon. You guys ought to know. You're winners. All right. So there it is. It's a very interesting article about how this whole door got open to what you guys are doing right now. And there are a couple of interesting articles, not the least of which is
They did a lot of that too.
they used recyclable paper back then. Or at least they didn't know, but it was recyclable. There's a couple of articles in here.
I did too.
One is about, where is it? Germs on the moon. There it is. Precautions on the bottom there. Taken. Moon germs. Seriously, folks. You think you got it bad now with the STDs and stuff? Watch those lunars. And then there's another one.
Moon cooties.
That some people are actually working on right now. And it's this one. Huh? You think Caterpillar's starting something new? This excavating on the moon has been going on for a long time. It's just gotten a little more high tech. But the best article of all, because it's Monday, everybody, and I know this is a distraction, but I'm trying to wake you up. When 3 Rochester women watching television saw President Nixon talk to the moon explorer Sunday night, they tried to get a call through. We dialed 411 for the information operator to get the area code, one of the women related Monday. However, we were told that we'd have to dial 0 for the operator. They did. Told the operator they wanted to make a long-distance telephone call. The operator asked to where? The moon. The woman answered. Do you have the number, please? Alrighty, let's get into the material today. There is one mistake that was captured over the weekend. And it's that little minus sign.
Yep.
Yeah, you got that? That was a typo. It was a copy typo. This should be a minus. Okay? And if you work it out, when you enter that code, you'll see the minus there. You're right. It should be minus. Okay? So that'll be posted. Any other glitches on the exam? Yes. Problem 4C. I'm channeling you now, so. All right, problem 4 is this. Yes, what about it? Is it D to C or is it C to D to C? It's D to C. I see, said the blind man as he saw. Scary, isn't it? Yes. Obviously. Good, good. Well, if you guys don't get a job, at least you can be proofreaders. You know, after the big to-do, the hubbub of the 69 Apollo 11 landing, by the end of the 70s, true story, aerospace engineers standing on street corners looking for jobs. That was when the funding for NASA got really zapped, and the aerospace industry just let go of tons of really top-notch engineers, and they couldn't get jobs. So you laugh at that proofreader thing. Don't laugh. Be a proofreader for another Harry Potter series. Any other glitches? No glitches. Yes.
So it's a question. So for the figure 4C where it's written,
Yes.
is it the Bode plot of GCS and GCC, or do you want us to like write what we found, which is like the G hat CSS for the Bode plot?
Oh, that should have been. I see what you mean. Overlay the Bode. That's in D. In C, right?
Yeah.
Overlay GCS, that should have been copied to G hat CS, shouldn't it?
Yeah.
That's what it says in the actual problem. You guys are so good. Seriously. Go over to the English department. It's much more interesting over there. No. Okay then. Oh, ouch. That's not very nice. That should have been obvious though, right? It is a correction, thank you very much. But some of those, take a little initiative. All right. Others, clarifications, glitches, whatever. This is your time. It's your week. It's Dead Week. We can all watch The Night of the Living Dead. You can do that night, right? Where's your hat? You look weird. Sorry, I just don't recognize you without your hat. Other comments? Glitches? Clarifications? Questions? Anything? Don't tell me you haven't started. Yes.
When it says what mode is improved most, I think it was the second one.
Yep.
Do we plot all of them?
Yep, you do.
Okay.
In one plot.
Right.
It'll just give you all four of them. Yes.
For 3D,
Okay.
where it says at the end of the question 3D, the equation GP of Z equals.
Yep.
I guess I'm not sure what the Z.
That's Z transform out. Yep. This means, that's a good notational question. This, I haven't used it, but this is my Z transform, just like Laplace transform. So, yeah. This is where you go to the table.
Related to that question, do you want us to prove that the numbers from A give us the numbers in B using that, or do you want us to prove just the equations from the tables resulted in?
Use entry 22 to show that this is indeed the case. You're going to have to compute this, right? But you're going to need the table for this. And then you work out all the math, put in the numbers, and you should verify that. Does that make sense? Before we move. Well, no. If you've got a question on it, very likely other people have a question on it. Other people on this particular point. Help me clarify. Yeah.
So do you want to see the whole analytical solution and show that?
Yes. I want you to actually use your table. You will find a pair very similar to pair number 21, but with the additional 1 over s in it, right? That's why it's 22. It's one bigger than 21. It's like your amplifier, right? And then you will get an expression for this, and what you will find is that various z's cancel, and then you stick your numbers in, and lo and behold, you should get exactly this. To see where these commands are coming from. That's the point of this problem. Basically proving that that command does actually integrate the zero order hold into this transfer function.
And should you also have to multiply that GPZ times the constant gain to get the numerator values for
No, you just take your GP of S right there. Take this directly, right, and stick it in here and apply 22. No other constants. Yep.
Does that mean that are we going to use the same values for B and A that we found in part A for part B?
There are no values found in part A. There are. The values correspond to this.
Yes.
But the T here is general.
Yes.
In part B is where you stick in the actual T to get this. Or this. Or this. So in part A, you leave T as general. In part B, you put in this number so that you actually get this final numerical transfer function.
3A, I don't understand exactly what you're asking besides just multiplying all those constants together to get those coefficients.
Not much.
Okay.
The majority of that problem is completing the squares with numbers. This is a completion of the squares in general for arbitrary AB, right? You don't have this AB here. You have this. You need to figure out what A and B are by completing the square. Good questions. Other questions? Yep.
3C. I don't know if I'm reading it wrong, but you asked to overlay 2 step responses, but the figure says 3 systems.
Oh, does it? The figure says all 3? Yeah, that was because I deleted one of them to make life easier for you. There used to be 3.
What specifically, what 2 should this be?
Overlay plots of the step responses of GP of Z and G hat P of Z.
And those are what we did solve for above, right?
They should be defined up above if they're not asking.
And we're using the, will we use the T that we're from part B? Or
Yes.
Will we use the T from part B?
Yes. Other questions? Yep.
1C, you give us 3 holds. So basically, one was find the gain, so I give us just 3 holds.
Yep.
So it's a fourth order characteristic polynomial.
No, there are 4 poles.
There's 3.
No,
there's 2.
There's 4 poles. There's the fugoid poles 1 and 2, which are repeated, but just repeated poles. It's not 1 pole, it's 2 poles.
Okay.
This means sub 1 and sub 2. Remember, it's a you're right, it's a 4th order system. We have 2 modes, right? But they're underdamped modes, so that's why it's 4th order. So the fugoid modes, you want to place both of them right here. But there's 2 of them. So you repeat that. And then the other 2 modes are actually complex modes. So those are the 4 poles that you're going to put in there for your after command. Okay? Other questions? Yeah, that little subscripting, if you're not careful about what it means, can be confusing. I agree. Other questions? In fact, I like that because you just recognize that if it's a 4th order system, you have to specify 4 poles. So this is a good concept understanding, right? For Monday, I'm excited. Yes?
Yeah, on 1B, I'm just a little confused with the elevator impulse intensity of 1 million.
Yeah, if you were to do a unit impulse, you type impulse. That's called the unit impulse. Let's just talk really briefly because it's a point dear to my heart. It got me my first job. I told you this. If you have an impulse, a Dirac delta function, this is called the intensity. It is not called the amplitude. What's the amplitude of an impulse? It's infinite. What's the width of an impulse? So the amplitude doesn't exist, nor does the time on which that amplitude reside exist. Yes, that's right. That's an impulse. But the idea behind the impulse is when you integrate an impulse, what do you get? Think Laplace. What's the Laplace of an impulse? This is one. Don't complicate it. Put your hat back on. Keep the sun off your head. The Laplace of an impulse is 1. All right? Now we're going to integrate, but we're going to do it not with integrals, we're going to do it with Laplace. What's an integrator? So what's coming out in Laplace domain? 1 over s is an integrator because it's in this block, but 1 over s is also the Laplace of a signal, which is a step. And it's a step which has unit height. So back to your question, if this is an intensity of 0.1, this would be 0.1. Because multiplying goes through Laplace transforms. So the way, as I said in the last class, if you have a transfer function that looks like this, g of s, and you put in 0.1. This is the Laplace of the impulse. What do you get out? So, again, g of s is a transfer function, except when it's not. What is this thing called? Well, it's an output. All right, so what's the time domain output called? What was the time domain input called? An impulse. Go to the English department. If the input is an impulse and the output is the response to the input, then linguistically, what might we want to call the output? Ding, 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 ding. The impulse response. The transfer function of a system is the Laplace transform of the impulse response. Mathematically, is the transfer function of it. See, this is where man, if I had grown up in France, well, I wouldn't be here. But this is an essay question. Mathematically, the transfer function is this, right? Forget about the point one. Unit impulse in, this is g of s. Is the transfer function actually the Laplace transform of the impulse response? Well, mathematically, it has the same form. It's g of s. But is it g of s? Physically. Very simple question that goes back to units. What are the units of a transfer function? Output over input. Right? It's a ratio. You take the input with its units, you multiply this thing with output over input units, and you get output units. So this thing has units of the output. This thing has units of the output over the input. But mathematically, they're exactly the same equation mathematically. But they're not the same animal. So, back to this. If you don't have the ability, if the only thing you can do with MATLAB is give it the unit impulse, and you want to get this for the output, then what would you do? Multiply the 0.1 times your plan. Then you get exactly this for a unit impulse. Make sense? So rather than having this, you would do this. Okay, but understand, this is not the transfer function. This is a scaled transfer function to give you the output for a 0.1 intensity step or delta function. Other questions? Yes.
Stupid question for stupid answer. What's a state vector?
It's a subset of the national vector. We agreed. Stupid question, stupid answer. It's a vector means it's got more than one element. What's the dimension of the state? Look at the state variable. U, W, Q, theta. How many elements are in that state? 4. So it's a vector of 4 elements. So the vector of state elements would be, what you'd be plotting is the response U, the response W, the response Q. Okay? And this is the thing about Edkin. Why in the heck didn't Edkin put alpha for W? What is U? What is U? Cody?
That's just me.
Stupid question, stupid answer. What is the variable U, Cody? Test your 355. Anybody?
Basically your velocity, isn't it?
Which velocity?
Forward velocity.
Forward velocity, yeah! Right? And that's the one that's going to control the phugoid mode. Right? What's W? Vertical velocity. But nobody talks about the vertical velocity. What do they talk about? is u over the speed. And I like alpha because I like pitch, right? So you can convert that to an alpha form if you want, to a state vector with alpha instead of w. But no, it can have to say, we're going to keep it in w, just because I know more than you do, just without a doubt. Does that answer your question on state vector? Yeah. And then we have county vector. What's a county vector? What's an unincorporated vector? It's a really small town.
We just don't talk about it.
That's right. We drive through those towns at 55. Other questions, comments? Oh, we're let's go to the back and oscillate a little bit here. Yeah.
Number 2B.
2B. You're just doing that because it's mainly right. 2B. Or not 2B. It's my favorite. All right. Problem 2B. Yes.
So it says your root locus gain should be equal to 1 here.
Yes.
Where your pole is -5 plus or minus 5.
Does everybody see that I'm actually giving you information about the exam? But it's important information. This is a little bit of a weirdo because you've already designed your controller. Remember, the whole idea of root locus is you leave that controller gain k flexible, then you plot the root locus and you choose a k that gives you the poles that you like. That's how we've been doing it all semester. Well, in this particular problem, you've already got your gains. There is no k vector, right? But if you do the root locus for this controller with these two numerical gains, when the root locus variable gain k equals 1, you actually have this. You don't have a scaled version of it. You actually have that controller.
Okay. So, like what I did was I took my K1 and K2 that I got from Part A.
Yep.
I plugged it into the GC.
Yep.
And then created the open loop transfer function that takes the root locus, and I'm getting a 0 or a pole at S equals -5 plus or minus 5.
You're getting a closed loop pole. I mean, you've got to be careful about open and closed loop poles. So you're doing your root locus, right? You have your plant, you have your controller, you get your open loop, and then you say our locus to show the closed loop poles is a function of gain.
Right. But it's for some reason saying that the gain is 0 at...
At 5?
-5 plus or minus...
Then you did something wrong, because if the gain is 0, you're at an open loop pole.
Okay.
Remember the open loop, let's just do a root locus for something that looks like this. Okay? What's the closed loop root locus look like? Well, go to the real axis. First order of business, go to the real axis. What part of the real axis is on the closed loop root locus? It's the only rule you really have to remember on root locus. Everything to the left of the circle. So this is all on the locus, but this is for k equals infinity. This is for k equals 0. And so you've got this entire thing on the root locus here, but the arrows have to be going this way. Because as k increases, you go to the zeros. K, right? So it has to look something like this. Now, if you've got this thing as -5 plus I5, you've got because this is k equals 0. Then you've got this thing in your open loop transfer function, which makes no sense because you chose K1 and K2 so that the closed loop characteristic polynomial would have that as a root. So something went flaky. Either you're using the closed loop, I'll bet what you're doing is you're not using the closed loop to do the root locus. Good. I don't know what to say then.
Was I doing it incorrectly to do like to get A?
I don't know.
What I did was I used the ACCR command with the A and B matrix and it gave me K.
Which A and B matrix?
Minus
The
1.
wrong one?
I hope not.
Well, it is wrong actually. Somebody pointed that out for me too. How many people figured out that A matrix that I gave from Etkin is wrong?
Is it?
Only one. Oh, you did too.
I got negative gains.
Well, you can get negative gains. That doesn't mean the A matrix is wrong.
You messed up.
Can you change our A matrix?
No.
Keep it like that?
Keep it like it is. Why is it wrong? 32.2.
Oh, I wonder about that.
Where I come from, it's 32.
They teach us 9.81, so.
I'm a little higher than you. Gravity doesn't affect me as much as it does. Yeah, you take your, right. I mean, you have your uncontrolled system, A, B, C, D, right? That's actually given to you. So with that that's your plan. And now you're going to use ACCR. The ACCR command places it's like a multi-dimensional root locus, except without the plot. You tell it the closed loop pole. Remember, with root locus, really all we ever did was place one pole and then do the angle criterion to get there, right? What ACCR does is pretty cool because you can place 3 or 4 or 5 poles and it'll figure out all the gains, and some of the gains may actually be negative. But, yes, that's the procedure. Use the original A, B, C, D. Use ACCR to get K1, K2, and then compute the closed loop characteristic polynomial.
And then, so to do that, you would recreate your A matrix, multiply by the K's, A minus...
You're now asking me a more kind of how to do the problem kind of thing. What changes in state space feedback control when you do pole placement? You start with an ABCD. What?
A and B change.
Does B change?
No.
Why does only A change? Because remember, from 355, the eigenvalues of A are the system poles. So all your feedback does is change those eigenvalues. So everything is wrapped up in A. The new A is related to the old A. And I can't tell you how at this point.
I think I know how it is related. So then you just create the new...
So you have A prime, B, C, D. None of those other things change.
Right.
And then you convert that to a transfer function. You could use that new A prime directly to get your characteristic polynomial for the closed loop. How would you do that? Pardon? No. Do you have Mathematica? As a function of S, you're going to give me the polynomial? How in 355? Remember what is the information in the characteristic polynomial? The roots. The roots are the information. If you put that characteristic polynomial into its factored form, S minus S1, S minus S2, S minus S3 minus S4, you have 4 roots. So now using only A prime, the new A, how would you get those roots? IA, that's what we did in 355. And then you have S1, S2, S3, S4, so you can write S minus S1, S minus S2, S minus S3, minus S4, and then you multiply that whole thing out, and you get your characteristic polynomial. The easy way to do it is use the state space to transfer function, because that does it all for you, and then somewhere in that transfer function is the characteristic polynomial. Okay. Yes.
So I guess one more thing for TB, what's the tolerance for how close
Close enough.
you get until the whole group got close to
Yeah, close enough. It's not going to be exact. It's going to be close. If you're off by an order of magnitude, if you're off by multiples in k, like k is 3 or 4 or 5, if it turns out that for k equals 0.97 or for k equals 1.1, what I did in my solution, that's a good point. What I did in my solution is I got a result that wasn't as close as I was happy with. And the reason it wasn't as close as I was happy with is because my MATLAB's default K array had a resolution that was 2 quarters. Remember, when you do R locus, MATLAB chooses the K values that it's going to evaluate the locus on, right? You don't choose it, you just trust MATLAB. But in this particular case, MATLAB tends to choose the resolution in the K increments to be sufficiently big that you're not going to get a good answer. So what I did is I defined a K vector from 0 to 2 in increments of 0.00001. And I got a better answer. No, just show me the root locus and show me the data. You have to remember, on that root locus, if you don't have a data cursor that shows me, and you don't discuss it, because if you have a data cursor, this happened in exam 2, people had a data cursor, and then I was supposed to infer from the information on the data cursor that you answered the question. Well, I did infer that until I got a number of people who actually had the data cursor information correct but gave me the wrong answer, which indicated they had no idea what the data cursor information was giving them. And at that point, I went back to all the earlier problems and I started taking points off. Because it's conceivable that you have the right data cursor information, but you don't have a clue as to what that information is telling you. So talk a little bit. Say, based on the data cursor, k equals blah, 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 my roots are blah, 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 everything's fine. Other questions? Yes?
Just clarifying, in A, W of S is equal to the scaled version of W hat, right? Or am I missing?
Yes. I'm pretty sure that's what it's supposed to be. Oh, you mean in problem 2?
In 2A, yeah.
Yep. Scale W hat so that W has unity static gain. W hat will not have unity static gain. But you need to give me W hat. And then when I'm grading this, if I see your W hat, I can identify the static gain in my hat. Right? You should be able to, that's why I want you to give me the W hat, to know where your static gain, so that W plus unity static gain comes from. So again, there are 3 answers here. One is the K matrix, right? Just 2 numbers. The second is W hat, or under hat. And then the third is W. And you don't even have to tell me what the static gain is. If you show me W hat, I will know immediately what your static gain for your W hat is. And if you show me W, and it has unity static gain 1, I'm going to, and it has the same denominator as W hat because it doesn't affect the poles, that multiplying a transfer function to change the gain in no way affects the denominator of the transfer function. So it'll be really easy for me to grade them. Other questions? Good question. See, you actually did learn something. You may not think so, but when you get that proofreader's job, tell them, if it comes to assessing some science articles, I may be able to proofread it. Right? Other questions? Comments? Yes.
So for problem 2D,
Yes.
how are you supposed to, I see that we're just supposed to like add a third row for the state vector.
I already added it.
Okay, I mean we're supposed to use that, but then how are we supposed to like implement that in the expression?
That's the problem, isn't it?
Yeah, but how are we supposed to do that again? I'm not sure how we're supposed to do that.
Well, all I will tell you is what is the definition of x3?
This is the prediction of y.
So what's x3 dot?
Y.
But what is y? Thank you.
Oh, okay.
Other questions?
So 2D is just n with 1, right?
Yep.
You're just doing a proof basically.
Exactly. I want to see 3 by 3s there. Any other glitches, clarifications, fishing? We're getting in the musky season. Set your bait. Nobody? We good to go then? Continue? Oh, it's 10 minutes? We only have 10 minutes left? What do you want to talk about? No, I mean, this is your week. I've got material that I can talk about. We can go into the controller design stuff more. I've already talked about it. But if you've started working on the exam and you're having questions about concepts and you can bait your hook in such a way that it doesn't look obvious that you're fishing for answers, but you want concept clarifications, it's your time. Anybody? No other questions?
Yeah.
Should we? Yes.
The notation of the hat, is that same throughout the whole exam? Or any definition?
Well, it means it's different than the one without the hat on. And again, it's a small point, but if you start confusing and not seeing that hat there, the questions are going to become nonsensical to you. So be really sensitive to whether there's a hat there or there isn't.
So hat in one problem should be a different definition than that.
Oh yeah, yeah. By the way, since we're on a Monday thing, and this little birdie came to my window, and how many people have signed up for 432? A few. Okay. How many people have not signed up? See, not many people raise their hand. I know. A little birdie came to my window and said, "Hey, you know what? You're scheduled to teach 432, but I'll bet you're not." What have you been smoking? I didn't think birds smoked. So just a little heads up, folks. If it turns out that for one reason or another they have me teaching structures, I was on that. I was scheduled to teach structure. You didn't know that? Oh, if you think 355 was a hoot the first time I heard it, structures would be an even bigger hoop.
You can teach 426.
Huh?
You can do 426.
Well, I was scheduled to teach 426. And then I emailed Ambar Mitra and I asked him, is this a mistake? And he said, yes. Well, after this weekend with a little birdie, you never know. So those of you who are taking 432, just a little possible heads up that I might not be the one teaching. Okay? All right, guys, have a good day, and come in loaded for bear on Wednesday.